Welcome all. Today, we would like to present to you about NetFlow Analysis Suite project for a digital forensic class at NYU Poly. We work as a team on this project, myself, Frat Burden, and Greg Babayev, who will be doing the demonstration part of this the presentation. First, let's talk about NetFlow. What is NetFlow? Well, each package contains certain information. In the certain information, they all encapsulated, which means, application layer encapsulated into transport layer, and transport layer encapsulated into the IP datagram, and IP datagram has all the information as well, and on top of the Ethernet frame in that package. So, flow is an aggregated records of packets. Flow should have at least these attributes. It should have source IP, destination IP, source port, destination port, transport protocol, and ICMP, IPsec, etc. So flows are typically unidirectional. And one thing to consider that flows typically do not contain data link layer, which means in terms of data reduction, since this information is not contained in the package, the PCAP is very large size than the actual NetFlow itself. So how network flow of data can help? Well, you can find out what's on my network, top host sending and receiving data, top applications currently on the network, what happened before and after event, and any policy violation, where they occur, and what are the most popular websites, how much blacklist integration help for traffic volume, any spammer on the network, anyone scanning our network, profile network with anomaly detection. One significant thing about anomaly detection, you can basically compare your traffic. Let's say last week this time what was going on your network, and then what's going on at this time. You can actually compare with if the traffic is behaving, or if there's any network activity on your network that is not supposed to be. So when you do all this analysis, one of the things you can do actually basically profile your network. So what are the IP addresses, inbound or outbound, external networks, any suspicious activities, and tunneling, beaconing, scanning, specific types of malware behavior, known ports, protocol, peer-to-peer activity. So in order to do that, we basically use a tool called SILT. So what is SILT? It stands for the System for Internet Level Knowledge. SILT is a tool suite written by CERT Network Situational Awareness Team, designed for working very large data collections and collects data very efficiently. So while pulling the network data, SILT compresses the data, encodes the data, and average flow record drops down to 15 bytes from a regular average PCAP file, which could be 1500 bytes. And this allows you to keep the data for a long time due to storage, and it keeps flow in the binary as much as possible. This gives a tool to efficiency. It process binary data a lot better than an ASCII file, and command line interface with scriptability provides a powerful combination. So what's the record? Well, record contains source address, destination address, bytes, packets, accumulated TCP flags, basically any information that you would like to grab from that network flow. And when we do this presentation, we basically grab some of the data from certain sources, and one of them is a contagio dump, and we grab cronware pickups from that the website, and we also use malware traffic analysis.net. We grab pickups from there as well, and this slide actually shows that malware traffic analysis.net provides a behavior analysis of the PCAP, which allowed us to kind of confirm whether any blacklist IP is confirmed, or any kind of traffic that we're expected to have as a result. And we combine multiple PCAPs into the one, and the following command actually did that. This is how you convert a PCAP file into network flow data, and RW file info actually shows you about the file. And this part of the presentation, Greg Pavel will be doing a demonstration.
Thank you, Farad. So for our presentation, we're going to use some of those packet captures Farad just talked about to show you how this tool works. So the first component of our tool is actually called nfs.py, and here I'm going to be running it against purplehaze.pcap, which is a publicly available packet capture for TDL4 Trojan. So when I run it, it's going to generate a report in the reports folder. As you can see, that's where it is. This report has protocols used in that PCAP file, top 10 flows, and I can show you that the flows between these two hosts are most common. Protocols used here are ICMP, only 2 flows. TCP obviously is the most prevalent, and some UDP as well. We also have top 10 data usage flows for data, top destination countries. Show you that. So US is number 1 here from this IP address, Germany, and so on. Another interesting report we have is a scanner report, which in this case is empty. Actually, it doesn't have any data, but I will show you another packet capture where it will. It's basically detecting scans on the network or scans within that packet capture. We also have traffic by hour, which is all of the traffic for flows and basically the amount of information for that particular hour for that flow. This report can be large, but it's useful if you're looking for something specific during an investigation. We also have graphical charts. Here we have the traffic charts generated. We have the timeline, which is always useful for forensic investigation to see what IPs communicate with what. So in this case, this IP is talking to Google for a total of 15 minutes and 44 seconds. We also have some DNS traffic here to Comcast DNS server. Here we have a breakdown by the amount of traffic for each source IP address. So this particular IP address is generating a lot of traffic. We also have the destination by traffic, and this is the IP address that downloaded the most, it seems. Here we have 10-minute intervals, so buckets of 10 minutes of traffic, and they're graphed out linearly. So this would be helpful in maybe DDoS, or just be able to see spikes of data usage on the network. And of course we have the geographical map. Geographical map shows us which flows are most common with which countries. So in this case, Russia, Romania, and Canada. Alright, so for the scanner report, I can do a demonstration with another packet capture. It's publicly available. And if we go back to the reports, for this one, as you can see, the scanner report is populated. And of course, we detected the SYNSCAN, protocol 6 TCP, the time, start time, end time, how many packets, how many flows, packets, and so on. Alright, so that's part 1 of our suite. Part 2 is a tool that actually goes out to the web and downloads publicly available blacklists of IP addresses and then compares it to the net flows inside the packet capture given. So go ahead and run this for the same packet capture. We see that we have the report, basic report, that shows us the flows that contain blacklisted IP addresses, and we can go ahead and confirm that these are malicious by maybe searching. And as you can see, this is a search hijacking Trojan, changes the host file. This is helpful in forensic investigation to quickly identify whether or not this host was infected or was connecting to any blacklisted IP addresses. So, keep this open actually. Okay, and we have also graphical representations here for the blacklisted only IP addresses. As you can see, we only have a few IP addresses. The response traffic only from this guy, this particular address. We have the same blacklisted IP addresses broken down by the amount of traffic. And here we have the 10-minute intervals as well. And of course we have the same geographical representation of it too. Romania, Russian Federation, so on. So for this blacklist tool, I can show you a little bit of the code involved and how you can customize it quite easily. This is the part where it actually downloads the IP addresses, the blacklists, and you can just simply add one more line like this with your own URL by changing this line and have additional rules, basically IP addresses as blacklists. So the next portion of our next tool is actually really straightforward. It allows you to do quick searches. So here I'm already ran it, but basically the usage is you give it a flow file, which was generated by the previous tool here automatically, and you give it an IP address of interest, and it'll find the flows that are matching that. So as you can see, that's a lot of output there for the screen. We can of course expand it, or we can just redirect it into a file. And we can have it here. Take a look at it and see all the timestamps and the connections and responses and so on. So the next utility here we have is a simple one as well. It basically goes out, looks at the flow file, and gives us a list of all the web servers found. So anything with that's hosting something on port 80. So if we run it, it gives us this list. Again, we can redirect to that to a text file. .txt. And we have it here. And we have a list of all these web servers observed in that capture file. So this concludes our presentation. Hopefully you enjoyed it, and if you have any questions, feel free to contact us.